In this ACT video, we're going to take a look at graphing parabolas. What I have for you here is a coordinate plane, and we're going to look at the equation y equals x squared. Now, this is just a basic parabola. We call this actually the parent function. I'm going to use a t-table to graph this. And remember, you can always use a t-table to graph anything. You're just picking x values, plugging them in, and getting y values. So we're going to start with 0. If we plug in 0, that's going to be y is equal to 0 squared, which is 0. I'm going to pick 1, so y is equal to 1 squared, which is 1. I'm also going to pick negative 1. Y is equal to negative 1 squared, which is 1. I'm going to go ahead and pick 2, so y is equal to 2 squared, which is 4. Go ahead and plot that. And then I'm going to pick negative 2, so y is equal to negative 2 squared, which is also positive 4. All right, so what we have is a parabola. It's kind of a U-shaped function. And it's got some very distinct characteristics. First of all, this bottom part, this minimum in this case, that's our vertex. And we're going to look more closely at that when we talk about the standard form of parabola. Now, if we draw a vertical line through the vertex, then we call this our line of symmetry, or more specifically, our axis of symmetry. See, we can save some time graphing this by knowing that it is symmetrical. In other words, if you think about folding this parabola over that dotted line, then this point would lie on top of this one on this one, and all the other ones in between. I also want to point out to you, because I'm going to use this when we graph some more equations in a minute, notice this point right here, it is 2 units away from the axis of symmetry, and its corresponding point is also 2 units away. So we're going to use that counting technique to find more points to graph the parabola. So we're going to look closely at the vertex, the axis of symmetry, and we're also going to talk about the y-intercept. And the y-intercept in this case happens to be 0, and the y-intercept is where it's crossing the y-axis. So this one isn't very interesting. We're going to take a look at a couple of examples that are a little bit more interesting. But before we do that, we need to look at the standard form of a vertical parabola. And vertical parabola just means it's either up or down, but not on its side. All right, so this looks familiar. It might look very similar to the equation for a circle, and it's y is equal to a times the quantity x minus h squared plus k, where a cannot equal 0. Because if that were a 0, 0 times anything, and that would all cancel out. So from this, we can get the vertex. The vertex is actually found using h comma k. So notice how that's written in the standard form. It's x minus h. So when we get our number for our vertex, it's actually the opposite of what we see. What I mean by that is I see a minus h right now, but my coordinate is just a positive h. The axis of symmetry. The axis of symmetry, which is what we want to find after the vertex, is x is equal to h. And remember, h is just a number. And then the y-intercept is where the graph crosses the y-axis, and we find that when x is equal to 0. So we'll actually plug in 0 for x and solve for y. So let's look at an example. Let's graph y is equal to x minus 2 squared plus 3. Now, how do I know this is a parabola? Well, that squared piece tells me this is quadratic, and quadratic equations are parabolas. All right, so let's slow it down a little bit. The first thing we want to do is find the vertex, which is hk. So in this case, it's 2, 3. 2 and 3. You want to go ahead and plot 2, 3. Then you also want to find your axis of symmetry. And your axis of symmetry is always x is equal to, and it's x is equal to h, which is x is equal to 2. And it helps too, because it only makes sense, that it's the x coordinate. Okay, those are the same number. That's your axis of symmetry. Your axis of symmetry is always going to go through that vertex. So I'm going to go ahead and plot the axis of symmetry. It's a dotted line. And then the next thing I need to do is find the y-intercept. And to get the y-intercept, we just let x equal 0. So we're going to let x equal 0 and plug it in. Y is equal to 0 minus 2 squared plus 3. 0 minus 2 is negative 2 squared plus 3. Negative 2 squared is 4 plus 3, so that y is 7. So let's plot the point 0, 7. Okay, and I kind of can't see my vertex, so let me go make that bigger, just because my dotted line got in the way. Now I'm going to find the other point that corresponds with my y-intercept. My y-intercept is 1, 2 units away from that dotted line. 1, 2, so I count 2 more. 1, 2. My red dot and my green dot are equidistant from that axis of symmetry. And you can find more points. You could plug in x is 1 and plug it in and get a value. You could plug in x is 3. Or you can stop right there and make this a U shape. It's definitely not a V. It's more of a U shape. And there's our parabola. All right, let's try one more. This one's going to be a little bit more interesting than the last because now I have that A, I have that coefficient. We're going to go through the same process though. The first thing we want to do is find the vertex. This is the order you want to do these things. So the vertex is HK. Well, this time that's a plus 3, so my vertex is at negative 3, comma, negative 1. My axis of symmetry is x is equal to negative 3. And just to remind you, this negative 3 and this negative 3, same negative 3. All right, we're going to go ahead and plot the vertex. So that's going to be at negative 3, negative 1, right there. And I'm going to draw my axis of symmetry. That's a vertical line passing through the vertex. And then thirdly, we're going to find the y-intercept, and we're going to do that by letting x equal 0. So that gives me y is equal to negative 1/2 times 0 plus 3 squared minus 1. And we're going to do our order of operations here, and y is equal to negative 1/2, parentheses, 0 plus 3 is 3 squared minus 1. And then we're going to do our exponent, so that's negative 1/2 times 3 squared is 9 minus 1. And negative 1/2 times 9 is negative 4.5 minus 1. And that gives me negative 5.5. So that's my y-intercept. And we're graphing, so I'm okay with that decimal. I'm just going to do the best I can to eyeball it right about there. Then I'm going to use the whole idea that this parabola is completely symmetrical, and I'm going to count my places over. So I'm going to take my y-intercept and I'm going to count until I get to the axis of symmetry. 1, 2, 3. So then I have to count 3 more. 1, 2, 3, and make my point. And this parabola is upside down because the A value is negative. That didn't quite make the dot, so you can fix that. Just make your dot a little bit bigger. So because this is a negative right here, I knew it was going to be upside down. If that was positive, it would be right side up. That may be a good strategy to use on the ACT because it is multiple choice, so that may help you eliminate some possibilities.